Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETOS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETOS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Welcome, everybody, to today's podcast. We've got an excellent guest. I'm very excited to welcome Francis Chow with us today. He's from Red Hat. He is the VP and General Manager of for in-vehicle OS and Edge within Red Hat, and definitely looking forward to the conversation we have today. But maybe first start with a little bit of background on Francis and how he got to where he is today with Red Hat. So Francis, maybe with that, I'd like to thank you for joining us today and open up the floor to you to give a little bit of background on yourself.
Hi, Eric. Thank you so much for your invitation to this podcast. As Eric said, my name is Francis Chow. I joined Red Hat about a year and a quarter ago, and I am responsible for driving and starting a new business for in-vehicle operating system. And about 6 months into my job, I have expanded my responsibility to cover all the edge business for Red Hat as well. Prior to Red Hat, I spent about 5 years at VMware, helping VMware build to $1 billion business, first with hyperconverged infrastructure and then on telco cloud. And before VMware, I spent about 20 years in the semiconductor industry, covering a wide range of roles from engineering to marketing to sales. And I was running a $1 billion business for the telco infrastructure towards the end. So I'm super excited about this role at Red Hat. That's why I came over, because we have an opportunity to transform an industry. And it's just super exciting to see how it's unfolding before our eyes.
Yeah, for sure. I totally agree. So Red Hat's been in the news a lot lately. It has, and your experience, let's say, in the semiconductor world, how do you see those two worlds, moving forward, let's say? Because I think it's definitely an interesting topic.
Yeah, absolutely. Because as you know, Eric, right, for a system to work, it requires both hardware and software to work together. And I've been in the semi business, right, for a very long time. And I've seen how Moore's law and technologies, right, that have helped transform many industries, increase performance, reduce power, get to the use cases we'll never been able to do before those innovations. And I would say that semiconductor has been driving a lot of innovation in past decades, and it's getting to a point that technologies are hitting almost a wall, right? Because as Moore's law getting to a point of 5 nanometers and 3 nanometers feature length, it's getting very difficult to kind of continue to scale that. And I think this is where software working with hardware is going to be critical on kind of bringing the innovation for new applications. And definitely software is going to be defining everything as we know it. In the past, hardware has been driving a lot of these definitions. And I would say in the next few decades, right, we're looking at software to define things, and we're going to bring more innovation to the world with software.
Yeah, so I think software-defined vehicles are a really big buzzword right now, and everybody has a definition of it. But I'd be interested in what your definition is of the software-defined vehicle based on your background, because I think it's an interesting question to me.
Yeah, I think if you look at what software-defined vehicle mean, I would say there are different stages of what that means.
Yeah.
In the early stage of software-defined vehicle, right, we're talking about functions of a vehicle driving more by software. For example, some of the infotainment system that you're seeing in cars today, where that has more feature driven by software than hardware, but still tied to the underlying hardware platform. I would say that's happening now, and probably in the next couple of years, what we're gonna see is software is gonna be more updatable, right? Meaning from your applications and services to the underlying operating system, right? They will be updatable. And what that would imply is that innovations can continue through the life cycle of a vehicle, and software will help define what that means to the customer. And as we look to the future, I think the vehicle is going to become a part of our personal ecosystem, right? We're going to be connecting the vehicle to smart cities, smart homes, smart healthcare, and all that, right, will become a giant personal ecosystem. And as we know it, right now it's already digitized, right? The way we interact with our
Yeah.
mobile devices, homes, and vehicle is just going to catch up to become a big piece of it.
Yeah, so obviously, I mean, Red Hat's been pretty prevalent, let's say, in the open source world. We as well as Red Hat are part of the Eclipse Foundation Software Defined Vehicle Working Group. But like from your perspective and your background, how do you see open source software playing a role, or let's say helping establish the foundations of the software defined vehicle and really enabling kind of what you were talking about is the vehicle becoming another edge device in the grand scheme of things.
Well, I think, Eric, the way we can take a look at open source is look at history. Let's see how open source has helped transform some other different industries and use cases. Right? Take a look at data center, right? The cloud, right? It's driven by open source innovations, and we are seeing open source starting to get into telco and service providers networks for a couple of years now, and helping to drive innovations in that industry. And I think we are now at the beginning of seeing open source helping to drive innovation and transformation for automotive. And I think the core tenet of open source is that because everything is out in the open, right? It provides a platform for customers and partners and end users to really come together to innovate, to drive innovation faster without having to worry about proprietary technologies. And I think this is what Red Hat believe, right? To leverage open source as a force multiplier for innovations, we can definitely drive progress faster to meet the business and customer requirements.
Yeah, right. So I think this has proven itself in other industries, but I think that the auto industry has, I don't want to say slow to adapt open source, but they definitely haven't embraced open source in the past. So in your mind, like what needs to happen, or what changes do you see in the industry? You coming in with a fresh perspective that would push the auto industry in the open source direction, because I think I agree with you. Like the rate of change we're looking to acquire, I mean, open source is the only way to achieve it.
Yeah, I think the automotive industry is starting to recognize the power of open source, which I think is a good thing. I can definitely appreciate coming from the outside, right? That why they're concerned about open source, because as we know that, right, the safety requirement for a vehicle, right, the security requirement for a vehicle, it's sometimes more stringent, right, than some of the other applications that open source are driving today. So definitely see the reason why there is hesitation for that historically. But I would say as we kind of look at uh, how open source can help automotive industry to meet the end user requirements, right? And to meet what the drivers are asking for. Drivers are saying that, hey, look at my personal ecosystem. Look at my mobile phone, right? The car is 5 years, 10 years behind those technologies. customers are asking for automakers to catch up on technologies, right? And I think this is the driving force for automakers to look at ways to accelerate their development, right? Reduce the cost of development and really get the time to market faster with new ideas. And this is where open source is there to help.
So one of the big things, at least in the auto industry, is we've got a bunch of different domains, right? Even within the auto industry. So you can talk about QM domain, you can talk about the ADAS AD domain, and when you get to this domain, we're talking about safety critical situations. And like, how do you think the open source adapts to the safety critical side of that equation?
I think we are in the beginning stages of finding ways to address those domains. As you said, right there, there are domains that are safety critical, and there are domains that what we call QM and quality management that are not as safety critical. But
Right.
I think what we're seeing though is that number one, right, there are consolidation of these systems, which means in the future we can definitely envision that a high performance computing system could be driving both safety critical and non-safety critical applications, which means your underlying operating system will have to support both. And so there's definitely a requirement, right, for the underlying operating systems to support safety, because both safety and non-safety applications workload will run on the same host operating system. And I think the good news is, right, Red Hat is now pioneering the way to certify functional safety on our Linux, and we're going to do it in an open source way. The code is in the open. In fact, right, you can actually download from GitHub today on where we are
Yeah.
on the progress of doing that. And this is something that no one has done it before, right? And I think the fact that Red Hat as the expert in Linux, and we have a track record and history of supporting mission critical applications for other industry for 3 decades, give us confidence, right, that we can help bring that expertise to the automotive market to help drive transformation.
And it's something that I think the industry's got to solve, right? I mean, without addressing the safety critical domain, you're kind of missing a big piece of what's required to support the auto industry as a whole. So I think it's like you said, it's something that the industry is going to have to solve here in the very near future. So earlier you mentioned, hardware as well. So and with your background, obviously, being coming from the semiconductor world, like, how do you see hardware, or let's say EE architectures, changing over the next few years to really help implement this the software defined vehicle, and the really create the vehicle as an edge device similar to how we use our phones and such.
I think at a high level, right? I've not designed hardware for a while, so I would put a disclaimer on that. But I would say
Yeah.
if you look at right the high level, right, the the chips, right, the device that we're using today are definitely higher performance than what was in the past. And the embedded control units in the past are also more purpose built, right? So the processing capabilities of those are smaller, right? The memory footprint of those is smaller, the capacities are smaller for memory.
Yeah.
And now you have larger devices with more on-chip memory. I think what that means is these memories can be accessible by like gamma ray attacks, right, or electrical interferences. So I think more uh, I would say innate protection capabilities are needed, right, to make sure that right any corruption on the memory will have to be addressed, right, through some mechanism, and that's also a combination of software and hardware, right? How do software and hardware work together, right, to make sure that if there's any hiccup, right, in either the software, hardware, or how we handle interrupts, it has to be addressed somehow, right, in the combination of those capabilities, so that the higher layer applications could still remain safe in any scenarios.
safe and then similar, let's say, or backwards compatible, even for, let's say, the non-safety critical domains from a developer standpoint, right?
Oh, absolutely, absolutely, right. And I think that the key thing to think about is in the past, you design the system, right, and the software is done, right. It's one and done,
Yeah, yeah,
and you
right.
don't have to worry about it. And in the new way, we expect the software to be updatable. We expect apps to be updatable, right? We expect the value of a vehicle to not decrease from the day of purchase, but potentially increase, right, with better software-defined capabilities. I think that really drive a different set of requirements on how software can be updated. Uh, but on the other hand, they actually allow some of these security features to be implemented as we go, right, to make sure that the vehicle is safer and more secure over time.
Yeah, right. It's safety and security, right? Both. And do you think this means that you either over design the hardware initially, or you design the hardware such that you can update the hardware over time, or maybe some OEs will take both paths? I mean, how do you see it going?
That's a good question. I honestly don't know exactly how it will evolve. I would say there are a couple options, right? I would say for the most part, we probably wouldn't expect the hardware to change because it's quite costly to rip off a hardware component from a vehicle. But I wouldn't rule that out, right? Maybe a couple years or a decade down the road, right? It could be as easy as swapping a blade, right, in a server, just like data
Right.
center in a vehicle. Potentially, right? That's doable. But I would
Yep.
say in the meantime, the more likely scenario is to rely more on software to kind of be applied to the hardware to enable hardware features that was designed in, right. I would say sometimes it's always a smart thing to design more than is needed in the current requirements so that the hardware can sustain some feature upgrades over a period of time.
Yeah, so that's interesting because I'm like you. I'm not sure. I know exactly how it'll go, but I know for sure that the life cycle of a vehicle is dramatically different than the life cycle of, say a cell phone, right? I mean, people don't expect to
Yep.
keep their cell phone for a decade, right? But that's what the expectation is going to be on the automobile. So making sure that the automobile can support updates through its life cycle and maintain its value is going to be one of the key things the industry is going to have to solve. I mean, just look at Tesla today. I mean, what are they doing? They're doing something one plus updates a week, right? I mean,
Yep.
yeah. So, and these updates are for all kinds of reasons, right? But it's definitely interesting to me to be at this time in the auto industry and see how it's adapting to, let's say, what the pull from the customer, because I think the value proposition changes a little bit for the new users, let's say, as far as, that maybe they buy a vehicle and they expect to be do updates to it, and they expect to be able to add and remove features and functions over time when they need them. I mean, how do you see it that way?
I think the fact that things can be software defined and things can be updated and changed definitely would change the dynamics, not just for the consumer, but also for the automakers, right? Because I think historically, it's pretty logical if you think about, hey, if the vehicle is going to depreciate from the point of purchase,
Right.
automakers would be incentivized to lower the cost to the lowest possible, right? So that they can maximize the profit, right? And then try to make sure that the car can be manufactured at an optimal cost. But now, if you think about the vehicle, might actually increase value over time, right? There are additional revenue streams that could be sustained over time post sale of a vehicle. You would start to think about, hey, maybe cost is the wrong optimization point, right?
Yeah, right.
Maybe the dimension
Exactly.
to optimize will be, okay, how do we enable faster innovation? How do we enable frequent change and updates, and maybe an open platform for application to be developed? So I think there's definitely a change on the automaker side. I think on the consumer side, I I think they need to push more, right? The consumers need to push for better integrations of vehicle into the daily lives, right? I'll give you kind of some examples, right? As my kids, right? They watch TV, and sometimes they're watching a show, and hey, we need to get in the car, right? And they say, no, we need to finish the show, right? But what
Yeah,
we should
right.
expect in the car is, as they jump in the car, they should continue to watch that they've been watching on TV, on Netflix, right? Why would there not be a possibility to do that, right? Well, it's because the car's ecosystem is not connected and advanced enough to support that, but they should, right? So I think consumers should continue to push for more. Technology is here. The question is, how do we take advantage of these things so that we give the end customers a better experience?
I agree. Although sometimes I wish my kids would read a book instead of wanting to be watching Netflix, but I think the seamless interaction. I think this is definitely something the consumers. I kind of feel like they're going to be pushing for it. I think it's going to be a prerequisite for playing in the space. It would be my take.
I totally agree. I think the bar is being raised now by some of the new players in the industry,
Yeah, for
and
sure.
everyone will find ways to get there over time.
Yeah, yeah, for sure. So, Francis, thanks a lot for taking the time to chat with us today. I really enjoyed the conversation. Any last words of wisdom from your side?
Yeah, thank you, Eric. I would say that it is critical for the community to work together to drive this change. I think the change that is needed to help propel this industry forward is so complex, right? So hard to do from the safety standpoint, from security standpoints, from the user experience standpoint. It really require everyone in the community to dive in and help. So my call to action is, if you're interested in the industry, or you are already part of the industry, whether you are in the hardware business or software business, or you're a tier one, or you are a car maker, right? Just be open, uh, look for ways of collaboration, because I think as we work together, we can really drive change. We can help transform the industry, and this is as exciting as I can ask for, on what we're gonna see in the next decade.
Yeah, so in closing, I just like to get a couple of shouts out to a couple of different things that we're a part of, that Red Hat, ETAS, and even Bosch are a part of. So the first is the Software Defined Vehicle Working Group within the Eclipse Foundation, as well as what we're doing with Sophie. I encourage you guys to do a little bit of Google searching. You think you can easily find both of these initiatives, but both of them are super important. I think, from my perspective, open source initiatives that will certainly help accelerate the growth towards the real implementation of the software defined vehicle. So, with that, everybody, I'd like to close today's session. I thank everybody for listening, and looking forward to the next time we get together to talk. Thanks.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.